Okay, so this video is going to be kind of a short one. It's going to be something that I think you already are pretty familiar with, but there's just a couple things that need to be said about this, and it's about linear functions. So linear functions is exactly that, like linear. What does linear mean? Linear means it's in a straight line. So this is going to be a function that is in a straight line, if you remember in our last video about what a function is. So you can always tell if it you can always tell if an equation is a function by their two ways. Okay, if you have the graph, you can tell one way. If you have the table, you can tell another way. So if you have the table, so you have x and you have y, and y is also considered f of x, and you have, I don't know, 0, 1, 2, 3 for your domain, and your range, which are your y values, go from, I don't know, -1, 0, 1, 2. Okay? If you have one y value for each number, okay, then it is a function. Now, if you have a graph and you're trying to determine if it's a function, then let's see that this is a graph, okay? If I do a vertical line through any of the points, I'm not going to pass any other point. That's going to tell me, or it's not going to go through any other point. That's going to tell me that it is indeed a function. So that's how you can tell if it's a function. Now, a linear function is going to go in a straight line at all times, okay? Now, the standard form for a linear function is ax, where a is a number. I want to make that very clear. A is a number, and x is the variable. B plus by, b is a number, y is a variable, plus c. So those capital letters are actually numbers. You would just put them in. So a, b, and c are real numbers. A and b cannot both be 0. If they are both 0, then it's not a linear function because you don't have anything in front of it for the slope. And the variables x and y. Okay, so you have to have the variables x and y. Now, say that it's y equals mx plus b. Is that still a linear function? Yes, it is. Okay, so this is the standard form. Okay, and this is actually, if you can remember, point slope form. Okay, so if you have 2 points, you can figure out that form. But these are linear functions. So they have the variables x and y. They have exponents of 1. Okay, so you can't have anything larger than an exponent of 1. So if you have x squared, that is an exponent larger than 1. Okay, because that's 2. The exponent is 2. They're not multiplied together. Okay, so if I had x times y, that would not be a linear function. And they are not denominators, exponents, or radical signs. So examples that are not linear functions. 2 plus 4 is 6. There's no variable. There's not an x or a y. Okay? Okay, and you have to have both in this case. Okay, x squared equals 9. The exponent's greater than 1. So it's not 2. The exponent 2 is greater than 1. Xy equals 8. X and y are multiplied together. We can't have that. X is 6 over x equals 3. Well, x is in the denominator, so that's not going to happen. 2y equals 8. Y is in the exponent. So you can't have your x and y in the denominator, exponent, or radical signs. And in this case, it's under a radical. So that is also not a linear function. Okay, a linear function is going to be either in standard form or point slope form. So both of those are going to be linear functions, but if it's not, then it is not a linear function. Okay, so I'm going to do number 1 with you guys and then scroll to the bottom, but the rest of them I want you to be able to do. So in this case, 14 equals 2 square root of x. Is that a linear function? No, it is not. Why? Because x is underneath the radical. X is underneath the radical. Okay, so it is not a linear function. So I want you to pause and do 2, 3, and 4 yourselves. Okay, now I'm going to look down here. So one way that you can tell if a function is linear or not is to make a table, just like we did with determining if something was a function or not. You can tell if it's a linear function or not if you make the same kind of table. So in this case, I'm given the problem here, which you can usually tell just by that alone if it's a function. But in this case, I want to finish my table of values to determine if it's a function or not. So if it is a function, you'll have constant change. Constant. Constant means it is the same rate. And just going a little further, same rate of change, if you've been in math for a little while, you know that rate of change actually means slope. Okay, so we're going to plug in a couple of x values to get some y values and see if this change is equal. What is that change? And that change is also going to be known as the slope. So I'm going to do the first one, then you'll do the second one. So if our x is -1, 0, 1, and 2, so these, again, going from our last problem, are our domains. So -1, so when I plug in -1, it already finished that for me. I have 1. If I plug in 0, I get 2. So let's plug in 1 for x. So y minus 2 equals 3 times 1. So we're going to say y minus 2 equals 3. And then we need to get y by itself, so we have that what y equals. So we're going to add 2 to both sides. So y is equal to 5. 5. Now I'm going to erase that just so that I have some room. Going back, now let's plug in 2. So y minus 2 equals 3 times 2. So y minus 2 equals 6. Add 2 to both sides to get y by itself. Y equals 8. Okay, now, how are we going to determine if the change is equal? So what you're going to need to do is I'm going to pick a different color here. So from -1 to 2, how many steps are we going? Let's consider that. -1 to 2, -1 to 0 is 1 step. 0 to 2 is 2 steps. So altogether, we're going 3 steps to the right. What about from 2 to 5? That's also 3 steps. 5 to 8, also 3 steps. So is that the same? Is that equal change? Yes, it is, because it's going 3 steps each time. Now, what is that change? Okay, that change is 3 every time. So that's how you're going to determine if it is a linear function or not. So I want you to pause this, and you're going to do number 6, and then that's it for our linear functions for today.